Science Audiobook, Class 9th, Chapter 2, Part 3. Properties of a colloid. A colloid is heterogeneous mixture. The size of particles of a colloid is too small to be individually seen with naked eyes. Colloids are big enough to scatter a beam of light passing through it and make its path visible. They do not settle down when left undisturbed. That is, colloid is quite stable. They cannot be separated from the mixture by the process of filtration, but a special technique of separation known as centrifugation can be used to separate the colloidal particles. The components of a colloidal solution are the dispersed phase and the dispersion medium. The solute-like component or the dispersed particle in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersing medium. Colloids are classified according to the state, solid, liquid, or gas, of the dispersing medium and the dispersed phase. A few common examples are given in table 2.1. From the table, you can see that they are very common everyday life. Table 2.1 Common examples of colloids. Dispersed phase, dispersing medium. Type example: liquid, gas, aerosol, fog, clouds, mist, solid gas, aerosol, smoke, automobile, exhaust, gas, liquid, foam, shaving cream, liquid, emulsion, milk, face cream, solid, liquid, sole, milk of magnesia, mud, gas, solid, foam, rubber, sponge, pumice, liquid, solid, gel, jelly, cheese, butter, solid sol, colored gemstone, milky glass. Physical and chemical changes. In the previous chapter, we have learned about a few physical properties of matter. The properties that can be observed and specified, like color, hardness, rigidity, fluidity, density, melting point, boiling point, etc., are the physical properties. The interconversion of states in a physical change, because these changes occur without a change in composition and no change in the chemical nature of the substance. Although ice, water, and water vapor all look different, the display different physical properties, they are chemically the same. Both water and cooking oil are liquid, but their chemical characteristics are different. They differ in odor and inflammability. We know that oil burns in the air, whereas water extinguishes fire. It is this chemical property of oil and makes it different from water. Burning in a chemical change. During this process, one substance reacts with another to undergo a change in chemical composition. Chemical change brings a change in the chemical properties of matter and we get new substances. A chemical change is also called a chemical reaction. During burning of candle, both physical and chemical changes take place. Can you distinguish these? Classify the following as chemical or physical changes: cutting of trees, melting of butter in a pan, rusting of almirah, boiling of water to form steam, passing of electric current through water and the water breaking down into hydrogen and oxygen gases, dissolving common salt in water, making a fruit salad with raw fruits, and burning of paper and wood. Try, try segregating the things around you as pure substances or mixtures. What are the types of pure substances? On the basis of their chemical composition, substances can be classified either as elements or compounds. Elements. Robert Boyle was the first scientist to use the term element in 1661. Anthony Laurent Lavoisier, 1743 to 4, a French chemist, was the first to establish an experimentally useful definition of an element. He defined an definition element as a basic form of matter that cannot be broken down into simpler substances by chemical reactions. Elements can be normally divided into metals, non-metals, and metalloids. Metals usually show some or all of the following properties. They have a luster, shine, they have silvery, gray, or golden yellow color, they conduct heat and electricity. They are ductile, can be drawn into wires. They are malleable, can be hammered into thin sheets. They are sonorous, make a ringing sound when hit. Examples of metals are gold, silver, copper, iron, sodium, potassium, etc. Mercury is the only metal that is liquid at room temperature. Non-metals usually show some of or all of the following properties. They display a variety of colors. They are poor conductors of heat and electricity. They are not lustrous, sonorous, or malleable. Examples of non-metals are hydrogen, oxygen, iodine, carbon, coal, coke, bromine, chlorine, etc. Some elements have intermediate properties between those of metals and non-metals. They are called metalloids. Examples are boron, silicon, germanium, etc. More to know. The number of elements known at present are more than 100. 92 elements are naturally occurring and the rest are man-made. Majority of elements are solid. 11 elements are in gaseous state at room temperature. 2 elements are liquid at room temperature, mercury and bromine. Elements gallium and caesium become liquid at a room temperature slightly above room temperature 303 K. Compounds. A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. What do we get when two or more elements are combined? Activity 2.4. Divide the class into two groups. Give 5 gram of iron filling and 3 gram of sulfur powder in a china dish to both the groups. Group first, mix and crush iron fillings and sulfur powder. Group second, mix and crush iron fillings and sulfur powder. Heat this mixture strongly till red hot. Remove from flame and let the mixture cool. Group first and second, check the magnetism in material obtained. Bring a magnet near the material and check if the material is attracted towards the magnet. Compare and the texture and color of the material obtained by the groups. Add carbon disulfide. Add carbon disulfide to one sulfur part of the material obtained. Stir well and filter. Add dilute sulfuric acid or dilute hydrochloric acid to the other part of the material obtained. Note: teacher supervision is necessary for this activity. Perform all the above steps with both the element iron and sulfur separately. Now answer. Did the material obtained by the two groups look the same? Which group has obtained a material with magnetic properties? Can we separate the components of the material obtained? On adding dilute sulfuric acid or dilute hydrochloric acid, did both the groups obtain a gas? Did the gas in both the cases smell the same or different? The gas obtained by group first is hydrogen. It is colorless, odorless, and combustible. It is not advised to do the combustion test for hydrogen in the class. The gas obtained by group second is hydrogen sulfide. It is a colorless gas with the smell of rotten eggs. You must have observed that the products obtained by both the groups show different properties, though the starting materials were the same. Group first has carried out the activity involving a physical change, whereas in case of group second, a chemical change, a chemical reaction has taken place. The material obtained by group first is a mixture of two substances. The substances given are the elements iron and sulfur. The properties of mixture are the same as that of its constituents. Mixture table 2.2 mixtures and components. Mixtures. Elements of compounds just mix together to form a mixture and no new compound is formed. A mixture has a variable composition. A mixture shows the properties of the constituent substances. The components the constituents can be separated fairly easily by physical methods. Elements react to form new compounds. The composition of each new substance is always fixed. The new substance has totally different properties. The constituent can be separated only by chemical or electrochemical reactions. The material obtained by group second is a compound. On heating the two elements strongly, we get a compound which has totally different properties compared to the combining elements. The composition of a compound is the same throughout. We can also observe that the texture and the color of the compound are the same throughout. Thus, we can summarize the physical and chemical nature of matter in the following graphical organizer. Matter: solid, liquid or gas; pure substance, mixture; pure substance, elements cannot be broken down to simpler substances. For example, copper, oxygen, iron, hydrogen, mercury, etc. Compounds have fixed composition, can be broken down into elements by chemical or electrochemical reactions. For example, water, methane, sugar, salt, etc. Mixtures: no fixed composition, homogeneous, uniform composition. For example, sugar in water, salt in water, sulfur in carbon disulfide, water in alcohol, etc. Heterogeneous, non-uniform composition. For example, sand and salt, sugar and salt, water in oil, etc. What you have learnt: a mixture contains more than one substance, element, and or compound mixed in any proportion. Mixtures can be separated into pure substances using appropriate separation techniques. A solution is a homogeneous mixture of two or more substances. The major component of a solution is called the solvent and the minor the solute. The concentration of a solution is the amount of solute present per unit volume or per unit mass of the solution. Materials that are insoluble in solvent and have particles that are visible to naked eyes form a suspension. A suspension is a heterogeneous mixture. Colloids are heterogeneous mixtures in which the particle size is too small to be seen with the naked eye but is big enough to scatter light. Colloids are useful in industry and daily life. The particles are called the dispersed phase, and the medium in which they are distributed is called the dispersion medium. Pure substances can be elements or compounds. An element is a form of matter that cannot be broken down by chemical reactions into simpler substances. A compound is a substance composed of two or more different types of elements chemically combined in a fixed proportion. Properties of a compound are different from its constituent elements, whereas a mixture shows the properties of its constituent elements or compounds. Thank you for this time. Have a nice day. Take care.